Okay, our next topic is going to be another conversion, and we're going to be converting between grams and moles. So I'm sure you kind of thought about that in our last molar mass discussion. So molar mass, we're going to be using our molar mass as conversion factors. So once again, molar mass, you add up the masses from the periodic table, making sure to take into account those subscripts. So our first example that I want to do is I want to convert from 9.6 moles of iron sulfate, so FeSO4, and I want to figure out how many grams that is. So I'm going to start setting up my conversion factor. I'm going to take what's given here. So 9.6 moles, so MOL is our abbreviation for moles, FeSO4. Take what's given, put it over 1. Once again, very, very important that you are including what I'm talking about. I'm talking about moles of iron sulfate in this case. So we are going to set up our conversion factor. So we're going from moles, so moles has to go on the bottom. And we're trying to find grams, so grams will go on top. We should still include what compound we are talking about. You'll kind of see as we get further why it's very, very important to include this. So now we have to fill in our numbers that go in front of grams and goes in front of mole. Just like when we are going from moles to atoms or atoms to moles, wherever my mole is, always gets a 1. Next thing is we have to figure out what we're going to put in place in front of the grams of FeSO4. So this is where we calculate our molar mass. So when I look up my mass of Fe, 55.85, so I want to keep like 2 numbers after the decimal point. Mass of sulfur from the periodic table, 32.07. And oxygen is about 16.0. I have 4 of them, so 4 times 16 will give me 64.0. So add those all up, 151.92, and that's grams per mole, which is that's what our conversion factor is. So there's my grams over moles. So we are all set up, good to go. Let's cancel out our moles so that we're left with grams, which is what we're trying to find. So we just have to do 9.6 times 151.92. So when I put that in my calculator, I get something close to this. But let's go back to what we were given in the problem, 9.6. How many significant figures are 9.6? 2, hopefully you said. So we need to change our answer into 2 significant figures. So instead of what we just broke down, rounding it to 2 significant figures is going to be 1,500 grams of iron sulfate. So remember, those zeros don't count unless we have a decimal point, which we're not going to put a decimal point since we only want 2 sig figs. Label grams of FeSO4, so we are done. Next example, we're going to do the reverse. So this time I'm starting with 43.7 grams of lithium chloride. I got to figure out the formula. So lithium, Li, chloride, Cl. Lithium's a +1, Cl's a -1. No subscripts needed. Perfect. All right, let's get going. So we have 43.7 grams of lithium chloride. So take what's given, put it over 1. I'm going to set up our conversion factor. So this time we're doing the reverse. Grams of lithium chloride will go on the bottom so that they cancel out what I'm given. Moles of lithium chloride will go on top. So you can see we have our molar mass as our conversion factor there. So once again, wherever I have mole, gets a 1. Molar mass, I have to look up on my periodic table. So mass of lithium, 6.941. So I'll count that right there. Mass of chlorine, 35.45. So when I add those two, I'm going to get 42.391. Okay, so if you didn't want to show that work for your calculating your molar mass, that's fine. Just wanted to show you where I got those numbers from. So we're set up. Let's cancel out our grams of lithium chloride, so that way we're left with moles of lithium chloride, what I'm trying to find. So this time in my calculator, I'll plug in 43.7 divided by 42.391. So I calculate that, I get 1.03087919. But let's check back at what we were given. We were given 3 significant figures. So my answer has to have 3 significant figures as well. So I am going to round that 1.03, so that way I have 3 significant figures. We're going to label it, and I have moles of lithium chloride. Example number 2 is done. All right, so let's look at what example number 3 is asking me to solve. Example number 3 is asking me to solve for molecules, and we're given 29.1 grams of calcium bromide. Okay, so we can work with that. First things first, so we start with what's given. 29.1 grams of calcium bromide. Calcium's a +2, Br is a -1. All right, we got to add our subscript there. Take what's given, put it over 1. Okay, so we need grams to go on the bottom because we're trying to cancel out the grams. So now let's figure out what's going to go on top. We're trying to find molecules, but I don't know a conversion from grams to molecules. What we've been doing is we've been going from grams to moles. All right, so we can work with that. Let's go to moles of CaBr2. Okay, so that's going to let me cancel out my grams, but I don't want moles. I want molecules as my final answer. So we got to do one more conversion. We're going to go from moles. Ran out of space to put my CaBr2. Okay, and we are converting to molecules. So we're going to put molecules. Ignore my limited space, CaBr2. Okay. So this then will allow me to cancel out moles, and I'll be left with molecules. That's what I want to be left with, so we're good. Sorry. We have to now plug in the numbers, the values for each of these. Wherever I have moles, I want a 1. Same is true for my last conversion. Wherever I have moles, I want a 1. Grams of CaBr2, so you would go to the periodic table. Keep in mind you have 2 Brs, so you want to make sure to multiply that number by 2. When you calculate the molar mass, you should get 199.88 grams. So that will give me my molar mass of calcium bromide. And then we got to put in our number in front of molecules. So here we have our Avogadro's number, 6.02 times 10 to the 23rd. Hopefully you left a little more space on your page. All right, so now my conversions are all set up. We just have to calculate. So what I would do is multiply everything on top. So 29.1 times 1 times the 6.02 times 10 to the 23rd. So when I do that calculation, here's what I get. And I'm not going to round just yet. I'm going to wait and save my rounding to match sig figs until the very end. So then on the bottom, you would multiply everything on the bottom. In this case, we have 1 times 199.88 times 1. Easy calculation for me. All right, so then we're going to do top divided by bottom. 8.76, because we want 3 sig figs, times 10 to the 22nd. And my units are molecules of the calcium bromide. If you don't want to show this step, that's fine. You don't have to. I'm just showing you where that calculation came from. Sometimes it's more convenient to include that step depending on what capabilities your calculator has. And that's all I have for you for this lesson.